Hi everybody and welcome to your maths learning for today. So what we're going to do then, we're going to wake up our little brains and we're going to rewind to something that we did quite a long time ago when we were doing our addition and subtraction, but this is still going to be relevant for you today. So you can see at the top here, I've given you a part whole model, part whole. Okay, so I'm hoping that you've got part and you add it to a part, it will make your whole. Okay, so that is the first sentence that you can create using this representation. Okay, so do excuse my handwriting, it's very hard to do it on this. So a part plus a part equals a whole. Okay, so that's your first one. A part and a part equals a whole. Okay, so what I would like you to do is see if you can come up with the rest of those number sentences. Now, just to make it even more clear, what I'm going to do is I'm going to specifically label these part 1 and part 2. I'm hoping that you will realise why I have done that. Okay, so we've got part 1 plus part 2 equals the whole. Okay, so see what other 3 number sentences you can come up with. Now, just be careful, you've got 2 additions and then you've got 2 subtractions. So think, what do you know about subtraction already? Once you've had a little go at that, then come on back. So hopefully you've had a little go at that now. So the first one was part 1 plus part 2 equals the whole. Then I've still got another addition. Okay, so what do we know about addition? Is that it's just like multiplication. You can swap it around and it will still get you the same answer. It is commutative. Okay, so you can swap it and still get the same answer. So I know for this one, hopefully you have got part 2 plus part 1, very tricky, equals your whole. Because remember, when you add, you are getting the whole. Okay, now subtraction, then what do we know about subtraction? Could I do a part, take away a part and still get that whole? No, when we do subtraction, remember the whole goes first. So the whole is going to be taking away, let's do part 1. So if I've got that whole and I take away part 1, so almost like chop it there, I'm going to be left with part 2. And then another way I could, so could I just swap these round and do part 1, take away the whole equals part 2? No, because what always goes first when you're doing your subtraction? The whole. Okay, the whole must go first. So it's going to be the whole, take away part 2, and it should leave me with part 1. Brilliant. So hopefully you got those. I just want you to take a minute now, though, just to pause and just to explain how this can help me when I'm trying to solve problems. How can this knowledge here be really, really useful when we're solving our problems? So you want to have a pause and have a little explain. See if you can explain it next to this in your books. How can this help us? Fantastic. So that skill that we've just rewound is really going to be useful when we go later on into this lesson. Okay, but first we're going to do another rewind because this is also our main focus for this week. It is going to be our division. Okay, so here is a number sentence. I'm not going to read it. I want you to read it. And I would like you to first, do not just solve it straight away. The first thing I would like you to do is think about what this number sentence is actually telling me. Okay, so I'd like you to write a little number story to represent this problem. So think about the division, think about your whole, and think about those keywords, sharing, grouping. Okay, what is the story behind that number sentence? That's the first thing I would like you to do, a number story to represent what is actually happening in this problem. The second thing I would like you to do is then to finally use your short division method to solve the problem. Okay. Oh, I've just realised I've put short division problem to solve the problem. Short division method, there we go, to solve the problem. Okay. Once you've got that, you could always check your answer using a different method if you would like to, or if you are confident, you could try using your inverse, which we're going to be doing quite a little bit of today. Once you've written your number story and got me the answer, can you come on back ready to see what is next? Wonderful. So I'm hoping that you've had a go at writing a little number story now. Now, I'm just going to try and think of one off the top of my head. So my number is 1,698. That is my whole. Okay. So I might go for Miss Sison collected 1,698 seashells. Okay. She wants to store them in some little jars, so they look really pretty in her bathroom, but you can only fit 4 shells in each jar. How many jars will I need to buy? Okay, so that will really, really help me to work out how many jars do I need to buy. Each jar can fit 4 shells in, and I know what my whole is. So you see what my number story is there. Okay, so I've got 1,698 shells. I want to store them in jars that hold 4 shells at a time. How many jars do I need? So there, am I sharing or am I grouping? I know that there are 4 in each jar, but I don't know how many lots of them I need. So I'm grouping them into 4s to see how many jars I will need. So just have a think about your number story. Is your number story grouping or is it sharing? Just a little extra challenge for you there. So now I've got my problem. I'm going to actually work out my answer and work out how many jars I'm going to need to store all my beautiful shells that I've collected. So I'm going to use my short division method. Where's my ruler? Here it is. So I've got my 4 on the outside because I'm dividing by 4. And then on the inside, what goes on the inside, guys? The whole. So 1,698. Remember, draw it if it helps. 1, 2, 3, 4, 5, 6. 100s. And remember that these are really important that they stay in their columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7. No 10s. Forgot what I was doing then, guys. Do apologise. 10, 10, 10, and 10. Okay, so now I need to work out how many jars I'm going to need. Just tilt that down a bit so you can see my columns. It needs to go over this way a little bit. Okay, so 4s. How many groups of 4 can I make of these thousands? None, there's not enough, so I'm going to rename that into 10 100s. So now I'm going to have 16 hundreds. I know my times tables for my 4 straight away. I can do 4 groups there. How many groups of 4? I'm going to use my symbols down here to help me. I can make 2 groups and I've got 1 left over, so that 10 is going to rename into 10 ones. 10 more ones plus the 8 ones. I've now got 18 ones, and I'm going to use my 4 times table. 4, 8, 12, 16, 20. Oh, okay. So 18 isn't in my 4 times table. It's not a multiple of 4. So I know that I can go closest is going to be 4. And I remember my learning from yesterday. What do I do if I still have some left over? What do we call them? We call them remainders. So I need my R. And how many do I have left? 2. Okay. So Miss Sison seashells then. I'm going to need to buy 400, goodness me, that's a lot of jars, 424 jars, but I've still got 2 left over. So actually what I could do is I could buy 424 and just ignore my 2 shells, or I could buy 425 jars and just have 1 jar that's got 2 in them. 1 jar of shells. So there is the answer to my problem. Hopefully you got that, 424 remainder 2, and hopefully you've been able to answer your number story. Fabulous. So I'm hoping that's helped you to rewind your learning from the last few days. Now I've seen that you've all been doing super, super well with this method, and it's making me very, very happy. So today we are now going to be applying this method, because we're all confident at using this method now, and your knowledge of remainders to solve a range of word problems involving division. Okay, because as we say, it's not always going to be an easy peasy number sentence that you are going to be expected to answer. It might be in a tricky word problem or bar models for you to have to unpick, to give you that extra skill of unpicking the information that you need to take. So just thinking about your wholes, how many groups, or how many you're sharing between. Okay, that's my key knowledge for you today. Okay then, so let's wake our brains up then. Let's just see how confident we are with our short division method. So you can see here, we've got Miss Hall and her little maths group, and she's giving them 3 number cards on the board. Okay, and she's telling the children to rearrange the digits to make your own 3-digit number. Tell me a division fact about your number. So each of those children have created their own number using those 3 digits. Okay. The first part of the question is, what number could Zach have made? Okay, so Zach has told us that his number is a multiple of 6, which means it can be divided by 6 equally. Okay, so I've given you a little clue here. If you're not sure how to solve this, you could then think about your short division method. Which numbers could I put in which order to then make it a multiple of 6? Okay, once you've done that, is there any other possible numbers that there could be? Could you then rearrange them in a different way to get a different answer? Okay, and then what number did Rena make? Now Rena's is a little bit trickier. She's giving you her answer. Okay, so you know that when she divides it by 4, she gets 153 remainder 3. Okay, so this is where I put here a bar model might be really, really helpful to get your answer there. So you're almost reversing your short division method. Tricky one, that one. So that one might take you a little bit longer and a little bit more brain power, but I am very confident that you are able to do that. So have a little go at those 2 and then come on back to see how we got on. Brilliant. So I'm hoping you've had a little go at those now. So let's have a look and see how we could work out our answers. So let's start with Zach then. So Zach says his number is a multiple of 6. Now, I'm not sure how you did this, but straight away I drew my short division method. Okay, now we know it's a multiple of 6. So what I did first was I actually wrote down, and I wrote down my 6 times table. 6, 12, 18, 24. So my numbers, let me just write my numbers over here so I don't forget. So I've got a 5, a 6, and a 1. Okay. So what I did first was I was thinking about what numbers I could end in so that it would divide equally. So far, all I've got is a 6. Okay, a 2, I haven't got a 2. I haven't got an 8, so I can't make my end number fall in a multiple of 6. So then I know that straight away it is going to be possibly going to be divided by, because it's within that times table. Okay, so 24, 30, 36. Oh, here we go. So I could end with the 6, as long as I can get a remainder, a renaming of 3. So let me have a look. What could I do? So if I do a 1, that would then mean there would be none, and that would be a 5, which then would be 15. So 6s into how many lots of 6? 6, 12. I can make 2 lots, and that would leave me with 3 to rename, which would be 36. 1, 2, 3, 4, 5, 6. So 156 is one of your answers that you could have got. Okay, you see what I was doing there? Okay, so I wanted to make sure that this last number was equally divided by 6, because then I know that there's not going to be any remainders. I know it's going to divide equally. Okay, so let's use that knowledge then. So what I could do is, I'm thinking if there's any more. So I might just, let's see if it works if I just swap my 5 and my 1 round. I still want my 6. Is that still going to leave me with 3 to rename at the end? So 0, and then I've got 15. 50 more tens, so 51 tens. Oh, I need to go a little bit longer with my 6 times table. So 36, 42, 48, 54. So that's too many. So 48 is 1, 2, 3, 4, 5, 6, 7, 8 lots. 49, 50, 51. Yeah, that will leave me with 3. And there is my 6. Okay, so the 2 answers you could have got were 156 and 516. If you found any more, please do send them me across, because I will be very interested to see how many we can get between us. There's 2. Just see if you could find any more. Now, question B then, we're almost going in reverse. So I know that my answer, when it's divided by 4, is 153, remainder 3, okay? Now, the first way I initially thought about doing this was to use a bar model, okay? So here's my bar model. You see that? I'm going above that. Okay, so here is going to be my whole, which I don't know, but I do know that I've got 4 lots of 153. And then 3 that are left over, okay? So what I initially did, but I've just thought of another way of using this one, so you may have actually used that one. What I initially did my inverse. So something divided by 4 is 153. So if I then use my inverse and do 153 times by 4, that should help me to get my whole, because I know what this add this will equal to this. So 3 times by 4 is 12. 5 times by 4 is 20 plus the 1, which is 21. And 1 times by 4 is 4 plus 2 more, that's 612. But am I finished there? I've just about to write 612. That is right for this bar model, but will that give me the answer for this? What do I also need to remember that I've got 3 that are left over. So to get my original total, what do I need to do with those 3? I need to add them on, don't I? So 612 plus 3 will give me 615. So let's use our division method then to see if we were correct. So 615, how many groups of 4 can I make? 1, and we're going to have 2 that I need to rename. So now I've got 21, 4, 8, 12, 16, and 20. So that is 5 groups of 4, and I'm going to have 1 left over. 4 into 15, how many groups of 4? 4, 8, 12, 16 is too many, so 12 is 3 lots, and I'm going to have 13, 14, 15 remainder 3. There we go. Absolutely perfect. Well done to you. If you got that at home, a really tricky one, that one. Brilliant. Okay, so your turn then to apply this and have a little go by yourself. So question 1 then, Lexi has got these 3 digit cards. She's going to arrange them in an order in a 3-digit number. And she's giving you her fact that when she divides that number by 5, the remainder is 1. So think about your knowledge about the 5 times table. If you are dividing by 5 and there's 1 left over, that gives you a little clue on what your 1 digit has got to be. Okay, so have a go and see if you can find 2 different numbers that Lexi could have made using those digits. You can't use the same digits again. Okay, you can only use 1 in 1 space. Question 2, they've given you a bar model, so just like we've done here. So you can see there, they have got a remainder there, so they've just added it on the end. I'm going to note that down for next time I do my bar model, because I just put it on the outside, whereas of course it needs to be part of that bar, doesn't it? So what division calculation is shown here? So you just need to take that information and show the number sentence. And then B, when a 3-digit number is divided by 4, the answer is 47, remainder 1. So what is the number? So it's giving you the bar there to settle. And can you then work in reverse to get your answer, just like we did just have a practice with Rena's there. Once you've had a go at those, there's a little more of a convince me question here. So Richard has these digit cards. He makes a 3-digit number that he's divided by one of the other digits. Okay. His answer has a remainder of 4. What divisions could Richard have written? Okay. Is there more than one possibility? I feel like there might be quite a few possibilities there. So that one could keep you busy for a little while, but do keep persevering with it and see how many you can get, so you can get them all. So have a go at those questions for me and then come on back to see how you get on. Brilliant. So hopefully you've had a go at that now. Now, some of those really did hurt my brain when I was thinking about those. So I'm hoping that you have given it your best shot and you have used your perseverance skills to show that you, I'm getting all tangled up in my board here, using your perseverance, and you have managed to get yourself an answer. Okay, so 1, a 7, and a 9. They're the numbers that I've got to work with Lexi's number. Now, it says that when she divides by 5, the remainder is 1. So what do we know already about our 5 times table? They end in a 0 or a 5. Okay, so the ones is going to be a 0 or a 5. But if I'm going to have 1 left over, that means my number is either going to end in a 1 or a 6. Can you see how that is going to then divide by 5, but then leave me with 1 left over? Because this one, I might get a number that's to 20, but if I have 21, there's going to be 1 left over. I might get a number that divides by 5 times, 5 groups of 5, which is 25, but I've got 26. It's going to leave me with a remainder of 1. Okay, so I know that I haven't got a 6, so I know that my number needs to end with a 1, because then that is going to give me that remainder 1. Okay, so let's have a look at the other 2 numbers then. So let's try 791. Now I'm just trialing this, so let's see what happens. So 5s, how many groups of 5 can I make there? 1, I'm going to have to rename 2, which is now 29. 25 is 5 lots, and I've got 4 left over. 5, 10, 15, 20, 25, 30, 35, 40. I've got 8 lots, and I'm remaindering 1, just as we said, because 40 is divisible by 5, but 41 is going to leave me with that 1 left over. So the other possible answer then, I still need to keep that 1, because remember, I still haven't got a 6 for me to use. I still need to keep that 1. But what I'm going to do is just going to swap my digits round. So I'm going to put 9 in my hundreds column and 7 in my tens column. Okay, so this is a lot of trial and error. Okay, like I say, perseverance is key to this one. So I can make 1 group and I'm going to have 4 remainder. So now that's going to be 47 tens. 45 is 9 lots, and that's going to leave me with 2, which now is 21 ones. And then I've got 4 lots of 5, which will give me 20, but I've still got that 1 left over. So your 2 answers that you could have had was 791 and 971. So well done to you if you got that right. Okay, next one then. So they've given you that one. I think that was a bit of a mean first question. That was quite tricky. A lot of steps there that you would have had to use and lots of prior knowledge. So well done if you got that one right. Question 2, I think, is a lot more manageable. Okay, so 600, what is that number sentence? So think about a division. What always has to go first when you're dividing by a number? You always start with your whole, which is 683. What have I divided by? So how many equal groups have I been able to make? Is 1, 2, 3, 4, 5. I've divided it by 5. Okay, because remember that 3 is your remainder. Okay, because it's not another equal group. This is just what's left over when I've divided it into those equal groups. So you may have put 6 groups, but is that 6 equal groups? No, it's 5 equal groups, and then you've got your 3 remainder, okay? So I've divided it by 5, and my answer is, so how many are equal groups? There are 136 in each group, and there is remainder 3, okay? So let me just check that. Let's do our short division method to check our answers. I can make 1, and then I'm going to rename, which is now 18. I can make 3. And that is going to leave me with 3 10s left over. So then that's going to now be 33. So 5, 10, 15, 20, 25, 30 is the closest number I can get. So that is 6 lots. And I'm going to have 3 left over. There we go. My number sentence is correct. Well done to you if you got that right. Okay, so we're going to focus on B now then, okay? So they've already drawn out this bar model for you. So I'm going to just use my ruler to draw it out. How many parts are there? A hole underneath. Okay, so let me see. 1, 2, 3, 4. And then a smaller one. Just make those a little bit more equal. There we go. That one. Okay, so you can see here that I've set up this bar model and I want to work out what that hole is going to be. So this we know is going to be a 3-digit number. Okay, so let's have a little look at the information then. So it's divided by 4. The answer is 47, remainder 1. So let's just have a look at that question above. You can see that the answer was 136, remainder 3. So they had 136, 136, 136, 136, 136, and then the remainder 3. So I know straight away that this smaller bar, this smaller part on the end here is going to be what number? It's going to be my remainder 1, isn't it? Okay, so actually that bar should be a lot smaller. Okay, so my remainder 1 goes in that end box there, and then you can see here I've got my 4 parts. So when I divide by 1, I've got a remainder 1, but each of these parts is worth what? So it's something remainder 1. So it is 47. So I know that each of these parts are worth 47. Okay, now I can simply use my inverse for this bit, and I know that the first thing I can work out is what is the total of these bars here. Okay, let me just get my orange. So I'm going to focus my attention on this bit first, and then I can do my remainder at the end. Okay, so I know that I've got 4 lots of 47. So I can do 47 times by 4. Because remember, it's much quicker and much easier for me to times by 4 than it is to do my two digits at the bottom. So it's easier to just do a short multiplication. So 7 times by 4 is 28. 4 times by 4 is 16 with my 2 more 10s. So 16, 17, 18. And then I'm going to have another 100 because I can't put 18 in one box. So 47 times by 4. So this part of my bar here, I've already worked out, is 188. Okay. Am I finished? So is that my whole? No, it is not. Because remember, you've still got my bar goes all the way out here. Okay, this is just my bar for this part here. I now need to include this 1, this remainder 1 here. So this is worth 188, and I've got my 1 because I can't just ignore that. Because if I just got rid of that, look, that bar is not the same. They are not equal. So that is not my whole. Okay, so we need to do something with this 1. So what is it that I need to do? I need to do 188 plus, because remember my parts are plus each other. So just for a quick method, that's why I did times. But actually what I'm doing here is 47, add 47, add 47, add 47, add 1, which then gives me 189, which I think is my answer. How can I check my answer? I'm going to use my short division. So if I do 189 and divide it by, look at the question again, dividing it by 4, I should get 47 remainder 1. Okay, so the first thing I'm going to do is do my 4 times table. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, and 48. Remember, if you're not confident with your 4s, get yourself on Times Table Rock Stars, or there's lots of YouTube links for lots of really catchy songs. I remember this one from the song that I've listened to. 4, 8, 12, 16, 20, 24, 28, 32, 36. Okay, it sticks in your head. So the more you practice, the more confident you are going to become. So let's have a look then. Let's prove it. So how many groups of 4 can I make here? Well, none, because I've only got one. I can't make any groups of 4 in my thousands. So none, and my 1,000 then breaks into how many tens? 10 tens. So I've now got 18 altogether. How many groups of 4 can I make in this from my 18 tens? How many groups of 4? I can see here that I can make 16, which is 1, 2, 3, 4 groups of 4, but that leaves me with 2 left over. So 2 tens is the same as how many ones? 21. So now I've got 29 ones. So I'm going to do the same again. How many lots of 4? 1, 2, 3, 4, 5, 6, 7. I can make 7 lots of ones, which will give me 28, but I've actually got 29, which is going to remainder 1. So your answer for that question should be the whole was 189. Well done if you got that correct. Brilliant. So well done to you for applying your learning into those questions. If you manage to get onto your Convince Me, make sure you show your teachers all those amazing possibilities, because there are lots and lots. And if I spend all of this video doing all of the possibilities that you could have done, we would be on here for hours and hours. So we just want you to submit your answers to question 3, so that we can have a look and we will be able to tell you whether they are correct or not. Brilliant. So your independent activities for today, then we're going to be going into our practice books. Okay, just move myself out of the way. So page 36, you're going to be focusing on today. And you are simply doing exactly what we've sort of practiced and built up all the way this morning. So here you can see they've given you the bar model. Can you recreate the number sentence? And then can you do any working out that you need to in that box? Here, they've given you the parts. You need to work out what the whole is. Again, nothing too scary. We've done that already this morning. If you do get stuck, you can just rewind and go back to where I show you how to do this before each question. If you need a little bit more practice, that's absolutely fine. Okay. Then question 2 then goes on to you're proving if Max is correct or not. So you need to read really carefully about his answer and try and work out the correct answer, and then unpick where he might have made a mistake, or if he is correct, give him a well done. Question 3 is moving on to word problems. So instead of having that bar model, they've simply given you those word problems. So you need to pick out your question just like we do in class. So what is your whole? What is your part? And getting your answers. And then question 4, again, is a little bit of a bar model. Okay, so they've given you the length of the shelf, and they've told you that there are 9 boxes on the shelf. They want you to work out how wide one box is, so a little bit of a reverse there. So that might take a little bit more thinking skills and a little bit more application of your knowledge. But again, as always, go as far as you can, okay? We do not expect everybody to fly all the way through these. If you do get stuck on one, make sure you practice that, because there's no point going through all of these questions if you're still not very confident at, say, the first question, okay? So this is where we need your independent learning. Once you've had a go at those, you have got the challenge as always. And then everybody for me is having a go at that little explain it, reflect at the end, okay? So explain how you can check this calculation in 2 different ways, okay? So they've done 1,143 times by 5, and they've got an answer of 5,715, okay? How could you check if that is correct in 2 different ways? So show you're working out in your box here, okay? So think about maybe your inverse might help you. Okay, so 2 different ways that you could check if that is correct. I cannot wait to see all of your great learning today. You have absolutely smashed this method, and this is a little bit trickier than we've been doing, but as long as you keep applying that method and sticking to your processes, you will be absolutely fine. Can't wait to see all of your great work, and I'll see you all again soon. Bye.